Welcome to this lecture. In this lecture, I'm going to explain how we are going to use a linear regression model in order to do the house price prediction process. In this, the very first step is to import the useful packages such as NumPy, Pandas, train test split from sklearn, linear regression from sklearn, and useful performance matrices from sklearn. So in order to do so, and do this step number 1, we are importing NumPy as NP, import Pandas as NP. From sklearn.model underscore selection, we import train underscore test underscore split, and the useful machine learning model here is linear regression model, which could be imported from sklearn. And since this is a regression process, the useful performance metric is called as R2 score, and it is also imported from sklearn. Step 2 is to import or read the house price prediction dataset. So the dataset is available in the form of CSV. So this dataset named KC underscore house underscore data, it was downloaded from Kaggle website and it is being read with the help of pd.read underscore CSV syntax. So now our dataset available from the CSV Excel sheet is now transferred to this variable named data. Now, if suppose the data is having any infilled data or empty column, those empty informations can be identified with the syntax named isNull. And if suppose we wanted to leave or remove some of the unwanted features from the dataset, in the sense, it could be done with the help of the syntax named drop. Here, in this case, square feet underscore above is one column which could be removed with the help of this drop. Now, if suppose we wanted to convert some data, some dates which could be used if suppose values are equivalent to 2014, else 0 if suppose the values are in the form of date. So now the date column is now replaced with this 0 and 1 format. Right now, we have done some pre-processing such as identifying the null values, dropping one unwanted feature, converting the date format into zeros and ones, and finally rewritten in the data variable itself. If suppose we wanted to inspect visually what are all the informations available in this data set, that could be done with the help of data.head syntax. See, right now this is the entire data set available. So like say for example, this data.head function helps us to display first 5 samples of our dataset. When we scroll right, we could see there are several number of features named like price of the house, number of bedrooms, number of bathrooms, square feet of the living room, and so on. If it is hard for us to scroll towards right and see how many number of features are there, the number of features and entire information about the dataset can be inspected with the help of info syntax. Right now, we could see there are 90 number of such features. Okay, the next step is to convert if any string data available in the dataset, in the sense those string informations have to be converted into numerical data using suitable conversion. Why? Because machine learning model is easy to understand only the numbers and not the string. And in this dataset, fortunately, all the informations and features are available in the number. So this step 3 is unnecessary over here. Step 4 is to identify the dependent variable and the independent variable. Say for example, since this is the price prediction, house price prediction, the feature named price are identified as dependent variable, and the features such as ID and price can be removed from the entire data set with the help of drop function, and the remaining entire features can be stored in the X variable. Right now, X variable is carrying all the independent features and Y variable is having the one single column named price, which is nothing but our continuous label. So next step is to split this data set into training set and the testing set. So already we have imported this thing, right, from sklearn. train underscore test underscore split function. So right now we have X independent variable and Y independent variable separately holding entire 100% of our data. We are feeding this X and Y. This 100% data can be splitted into 80% of training and 20% of training part. As we have mentioned, test size is equal to 0.2. Next step is to define the machine learning model. Since this is the prediction process, we can use linear regression model. So right now I am using this variable named LIRE to define our linear regression model. And also I am going to train the model with the help of training independent part and training dependent part of the training set. So I'm doing the fitting process, which is equivalently called as model training. LIRE is a linear regression model that is undergoing train when you do this function named .fit. Now the model is trained. The next step is to test the model. While doing the testing process, we are going to hide the original test labels. We are going to feed only the test independent variables. So the testing can be performed with the help of syntax named as .predict. So the model predicted labels are stored in the variable named y_predict, and the original labels are already stored in the variable named y_test. Both the informations are displayed over here with this print function. Now, next step is to determine the performance of the model with the suitable metric. So already we have used R2 underscore score as our important metrics, as this is the prediction process. Right now, I am running this command where the original labels stored in y_test variable and the model predicted labels which has been right now stored in the y_predict variable are compared with each other in order to calculate the R2 score performance metric. You can see the performance matrix is 0.689. So right now we can do one certain hyperparameter tuning. Say for example, we have computed this model performance just by considering training test split as 20% of data set belonging to test size. Right now I am going to modify the test size to 30% instead of 20%. After changing this test size, I am running it again. I am defining the model and training the model once again. I'm predicting the model once again, and right now I'm going to compare the performance. See, before the performance was 0.689. After changing the test size as 30%, right now again I'm going to run this command. So right now you could see a small increment was there in the R2 score performance.